HTTP, HTTPS,
HTTP,
FTP, telnet.
yeah, HTTP,
HTTPS,
HTTPS,
FTP, SSH, Telnet.
FTP, SSH, Telnet,
Sir, sir, your screen is not visible.
not visible. How is it visible?
Yes, sir.
Yes.
Yes, HTTP, HTTPS, FTP, SSH, Telnet, then
SNMP,
SNMP, DNS,
DHCP,
DHCP, TFTP, right? Then guys, in TCP IP model, we have these layers: application, then transport,
Transport,
then network, then data link layer, network, or you can say internet, and physical. So these all application layer protocols can generate some kind of messages. You know, HTTP and HTTP, these are the two protocols used to access web page, right? Application layer is what? User interface. So this layer provides some kind of services like web service, file service, mail service, DNS service, DHCP service, file service, remote access service, and we can access these services with the help of these protocols. Through HTTP and HTTP, we can access the website, web. Through FTP, we can download or upload some file on the server. Through SSH and Telnet, we can access networking devices remotely. SNMP is a management protocol. Through DNS, we can resolve domain name into IP address. Through DHCP, we can configure IP address on devices automatically. And TFTP is also similar like FTP. Okay, so whenever guys these protocols is going to generate messages, they will forward the message to transport layer protocol. Can you tell me the function of transport layer protocol and protocols at transport layer protocol? This is good, very good. On application layer, you said these protocols. These are the important protocol only. A transport layer. What is the responsibility of transport layer?
End-to-end delivery.
Service to service communication. Service to service. How? How transport layer is going to guys
connection list.
identify the service with the help of port number. With the help of port number. And this layer is only going to decide the communication is going to be reliable or unreliable, slow, fast. With the help of again, these are services, and to access these services, we have what? Protocol. How many protocols are there? Two. TCP and
Two.
UDP.
UDP.
TCP, you know the difference between TCP and UDP? TCP is connection oriented protocol, reliable protocol, slow protocol, and UDP is unreliable. There is no any acknowledgement, but faster than TCP. So both the protocols are actually going to add extra information. That is the main task of transport layer. Both the protocol, whether I am using TCP or UDP, both the protocol is going to add some extra information with actual data. Actual data means data at application layer, which protocol has generated. And after that, what we call to data at transport layer? we call data to transport layer segment. What we call segment. So what is the meaning of segment? Segment means application layer data plus transport layer header. Transport layer header, and this transport layer header can be either TCP or it can be UDP. So what we are going to learn here at transport layer, if TCP protocol is going to be used, then what will be the extra information? What will be the information inside the header? You know few information, like there will be source port, destination port, you already know this, right? But there are some more information as well. So we'll see those all information in case of UDP also. And then transport layer will forward traffic to lower layer, data to lower layer, to which layer? Network layer or internet layer. What is the responsibility of internet layer?
IP address.
Network layer
Assign IP address.
assigning IP address, which segment, right? And how many protocols are there? Tell me the name of few protocols. By the way, at transport layer we have TCP UDP only. At this layer,
BGP.
IPv4, IPv6,
BGP.
huh? IPX, then EIGRP, OSPF. These are the protocol at network layer. Through this protocol, network layer is going to add source IP, destination IP, and some more information. We'll see those all extra information. But guys, I must tell you, for an example, even if you are going to access Google page or Facebook from your laptop, before sending actual data, of Facebook or Flipkart or Amazon, your machine is going to send lots of messages first. It is going to exchange around 10 packets. Directly my PC is not going to send request message. Before the request, if I am using TCP protocol, it is going to establish TCP connection. Then if it is a secure protocol, then transport layer only, we will have one more step, SSL connection, TLS connection to encrypt the data, DNS query and reply message. So these are the messages, these messages will exchange before sending actual data, right? So we'll talk about those all things. You need to understand the encapsulation and decapsulation only. What is encapsulation? Encapsulation means, you know what is the meaning of encapsulation, adding extra information with actual data. So how we are adding extra information with actual data? At transport layer, how we are adding, which protocol we are using, what is the payload? At network layer, which protocol are working, what is the responsibility? And it is only going to help you to troubleshoot the network whenever issue will be there. Whenever issue will occur, you will be able to troubleshoot. So encapsulation and decapsulation, according to the OSI model, guys, according to our first class, if I have one sender device and I have one receiver device, if I am going to send some data from this computer to this computer, sender to receiver, which device will perform encapsulation?
Sender.
Sender. And which device will perform decapsulation? Receiver. At which layer encapsulation will happen? At transport layer, network layer, and data link layer. At transport layer, by using which protocol? Either TCP or UDP. At network layer, by using which protocol? Either IPv4 or IPv6. In the same way, at data link layer and payload at network layer is what we call data at network layer or internet layer. Here we call packet. Packet means payload. Guys, payload means what? What is the meaning of payload? Can anyone tell me the meaning of payload? Payload plus header.
Data, actual data.
Yeah, kind of actual data, right? Maybe network layer have received data from the transport layer or from the any network layer protocol. It can be OSPF data, or it can be EIGRP data, or any network layer protocol data, ICMP data. So that will be considered as payload. Payload plus header is called packet. So when we will add IP address, source IP and destination IP with actual data, then we are going to call it packet. And then network layer will hand over packet to data link layer. This is the main responsibility of layers: transport layer, internet layer, or network layer, or data link layer, performing encapsulation. Clear? Here generally in the Ethernet we are using ARPA protocol. We have ARPA protocol which will encapsulate the frame here. Payload at data link layer is frame. Frame means again payload plus header. Payload plus right. So for an example, if I will talk about the packet flow, let's say here I have one computer and there is one server. This is web server, guys. Web server, www.pmnet.com. This is my website on this server. I'm hosting this website on this particular server. Okay, by using HTTPS protocol. HTTPS means it is secure. Right, IP address of this server is 10.1.1.10 and IP address of my computer is 10.1.1.1. This is PC, right? And if I want to access this website from the PC, what will be the packet flow? In the PC, I am going to simply open any browser, and in the browser I will type the domain name. I will type the domain name, yes or no? This is how I am accessing any website. If I want to access google.com or facebook.com in the browser, I can type facebook.com, www.facebook.com. Similar way here also I can open the browser, and in the browser I can type the domain name. Right, then what will be my packet flow over here? First of all, my machine cannot understand the domain name. My machine cannot understand domain name. My machine don't know pmnet.com, www.pmnet.com. My machine only know IP address. My machine can only forward traffic to IP address, cannot forward traffic to domain name. Right? So here we need DNS service also. Let's suppose for an example on the same server I have enabled the DNS service also. Now question is, what is DNS? At the same time, let's cover all application layer protocols also. What is DNS, guys?
It is all IP to domain name to IP.
Yes, it is used to resolve domain name into IP right. So whenever we are going to type domain name in the browser, my machine is first going to find the IP address of that domain name. My machine need what? IP address of that domain name, right? So my machine is going to look up for DNS IP address. Machine is going to check, hey, what is the IP address of DNS server? But guys, I have not configured any IP address. IP address of DNS on PC. I have only configured the IP of this PC, which is 10.1, and let's say MAC address of this PC is A, MAC address of this server is B. Right, so I have not configured the DNS server IP address. to whom this PC is going to ask what is the IP address of pmnet.com, right? So there should be one DNS server, right? Generally what will happen in the network, either you will be using public DNS server or you will have your own DNS server in your network. For an example, these are my employees and all the employees are connected to one centralized device, which is switch. They all have IP address, they all have internet access, right? At the same time, here I have one DNS server. Even you can perform this lab in packet tracer. I will show you, don't worry. This is DNS server. So on the DNS server, you have to create the database. First, you have to tell to your DNS server that what is the IP address of pmnet.com, right? So here I have to create one database. This is similar like your phone book, where you are saving mobile number with name. So here I will say www.pmnet.com is a domain name whose IP address is, let's say, 10.1.1.100, right? And the IP address of DNS server is 10.1.1. let's say 5, and the IP address of this machine is 10.1.1.1. And now if I am going to type www.com in the browser on this PC, what will happen? This PC will check DNS server IP address. First of all, here I will configure the DNS server IP address is 10.1.1.5. This time PC will see, okay, my DNS server is 10.1.1.5. So my machine is going to put the message on hold, which is the actual message, HTTP message, because in the browser we have typed www.pmnet.com. Automatically my machine will get to know that which protocol I need to use, right? My machine is going to call HTTP protocol or HTTPS protocol. Hey HTTP, come here, right? There is some task for you. See, someone is trying to access pmnet.com, right? Then machine will try to resolve IP address of pmnet.com. For that it will check DNS server IP address. Now DNS server IP address is configured. Now my machine is going to generate one DNS query message. My machine is going to generate one DNS query message, right? Source IP will be what? The IP address of PC 10.1.1.1. Destination IP will be what? DNS server IP address 10.1.1.5. Source MAC will be what? MAC address of this PC, let's say A. Destination MAC will be B, DNS server MAC address, because both belongs to same subnet. Later you will learn that concept also when we will talk about gateway, default gateway. That is next part of packet flow. Source MAC is going to be A, destination MAC is going to be B, and it will forward to switch will forward it to DNS server. And there will be layer 4 information also here, like source port and destination port. Source port number will be 1025 and a random port number, and destination port number will be 53, which is the well-known port number of DNS server. When DNS server is going to receive this DNS query message, right, DNS server will perform decapsulation. It will remove all the extra information at each layer, and then it will hand over DNS query to DNS protocol, and DNS protocol is going to not generate DNS reply message. And in the query, what will be the information? There will be domain name www.pmnet.com. Right? So DNS server will get to know, okay, someone is asking for the IP address of pmnet.com. DNS server is going to check their database. In the database, if entry is available, if IP address is available of pmnet.com, it will generate DNS query reply message response, DNS response, and in the DNS response message there will be IP address, right? And IP address of HTTP server is, let's say, same 10.1.1.1. It is going to say 10.1.1.1. Right? Again, source IP, DNS server IP address, destination IP, PC IP address 10.1, source MAC, DNS MAC, destination MAC, PC, and it will forward to. So now PC is going to store that entry in their cache memory. It will make one temporary memory. It will start maintaining one table in the temporary memory. That table is called cache table. In the cache table, it will store, okay, www.pmnet.com is domain name whose IP address is 10.1.1.10. So next time when you are going to access same website, it will not generate DNS query. So this is the DNS protocol here. After that, guys, after the DNS, what will happen? Anyone have idea? DNS server IP 10.1.1.5. After the DNS, at application layer, think which protocol is working, HTTPS or HTTP. But here I told you that my website is based on HTTPS protocol. And HTTP uses which protocol at transport layer, TCP or UDP?
TCP.
TCP. It uses TCP. And how many of you know TCP perform three-way handshake? What you know, TCP is an reliable protocol and UDP is an unreliable protocol. You know that?
Yes, sir.
How, guys? How? Because TCP establishes a connection, control connection before sending actual data, right? And UDP does not maintain any connection to send data. So if I will talk about three-way handshake, how three-way handshake will happen here? Three-way handshake. Again, we have same topology. This topology, let's say. This is my scenario. Server IP address is 10.1.1.10. Right. So what will happen? My PC, on the PC, transport layer have requested one message, one payload. Transport layer have one payload from application layer. Which payload? HTTP. HTTP protocol has generated one HTTP request message, that is HTTP get message actually. HTTP get message, which is the first message. Whenever you will open browser and you will type the domain name or IP address, your machine is going to generate, or you can see your HTTP or HTTPS protocol is going to generate get message. This is similar like request message, right? HTTP request message. Why PC is sending request message? To get web page from the server. When transport layer will receive this HTTP get message, it will check first which protocol I have to use here, TCP or UDP. So HTTPS is TCP based protocol, and you know TCP is a reliable protocol. So transport layer will put this message on again hold. This message will goes on hold again, and transport layer is going to first establish a connection, TCP connection, right? It will start maintaining a table, TCP table, right? For all types of TCP communication, first TCP connection will establish. Connection will establish, right? How? My PC is going to send one TCP header. What it will send? TCP header, and that TCP header is called SYN message. SYN message. Now why I am saying SYN message? Because guys, when I am going to teach you TCP header, you will see some flags are there in the TCP header. One flag is SYN flag. One flag is SYN flag. Another flag is ACK flag. Then FIN flag is there. These are the flags in TCP header. Many more informations are there. We will talk about each and every field. So actually in this header, in this TCP header, SYN bit is on. By default, all the bits are off. Right? So my PC is going to on SYN bit in their TCP header, and then it will send to server. In the SYN message, again, source IP, destination IP, port number, source port, destination port, everything is going to be same, right? It will generate SYN message. And what is SYN message? SYN is nothing but the TCP header with SYN bit on, okay? TCP header with SYN bit on. After that, there will be source port. Source port number is going to be any random port number. Destination port number will be what? HTTP port number 443. Then source IP will be there. 10.1.1.1. Destination IP 10.1.1.2. Source MAC A. Destination MAC B. This is the encapsulation of SYN message. Right? Source port and destination port are the part of same TCP header. Right? These extra information will be added by layer 3, and these two extra information will be added by layer. When server is going to receive this SYN message, server will check, okay, destination MAC address. Guys, you know, in 2 cases only server will accept this message at layer 2. What I am saying, in 2 cases only server is going to accept this message at layer 2. Otherwise, it will discard it at layer 2 only. First, server will receive the traffic at layer 1, physical layer. Physical layer will convert bits into frame. Then it will hand over to data link layer. Data link layer is going to check destination MAC address. And if destination MAC address is the MAC address of server or destination MAC is broadcast, then only it will accept. Otherwise, it will discard. Let's say destination MAC is C, it will discard. But if it is broadcast, then also it will accept. It will check layer 3 information, because if it is broadcast, then it can be for server also broadcast. If it is broadcast message, then that can be for me as well, right? Am I right, guys?
Yes.
So in 2 cases,
Yes, sir.
server is going to accept it. So here destination MAC will match. Data link layer will remove this extra information. Will hand over the packet to network layer. Network layer is going to check destination IP. Again, if destination IP is the IP address of server or broadcast, then only it will accept. Otherwise, discard it. So destination IP will be 10 here. 10. Right, so destination IP is the IP address of server. Network layer 3 will remove these extra information will hand over rest information to transport layer. At transport layer, it will check port number. Destination port number is 443, and 443 is which protocol? HTTPS protocol, right? In the TCP header, it will see SYN bit is also on, right? This message is for port number 443, means for HTTP. Again, in 2 cases only server will accept this message at transport layer if this port number is available on. Only in 1 case, if this port number is on, running on this server. So when you will configure HTTPS, when you will enable the HTTPS protocol, automatically 443 port number will open on this server. Now this port number is open. By default, only 1 port number is open on Cisco router, which is telnet port number, right? So if 443 port number is enabled, that means this server is HTTP server. It will accept, it will check SYN message, SYN bit is on. If SYN bit is on, that means someone is trying to establish a connection with me. Someone is trying to establish a connection with me. If this port number is not open on the server, then simply server will discard this SYN message and it will send one reset message to PC to inform that this port is not open, right? This port is down, right? So for an example, this port is running here on the server. So server have checked that SYN bit is on. That means SYN means synchronization, means someone is trying to establish connection. Server again, TCP protocol will generate one message for PC, and that message is called SYN plus ACK. SYN plus ACK message. Guys, what is SYN bit? Now if I will ask you what is SYN bit, so you can say SYN bit is a bit of TCP flag or flag filled, one flag in the TCP header at transport layer, which is used to establish connection. So now server is saying, okay, brother, I am also interested to establish connection with you. So that's why server is also going to send their SYN message. At the same time, as TCP is reliable protocol, server is going to give acknowledgement as well. It will on ACK bit as well. ACK bit is also one flag. So server is going to on 2 bit. SYN bit and ACK bit. ACK bit means I received your SYN and here is my SYN message. And then finally, my PC is going to give acknowledgement. And after exchange of these 3 messages, there will be one TCP connection. Now here you can check the TCP connection between PC and server. And over this TCP connection only, all the HTTP message will exchange. Right? Server have already reserved one port number for this PC. Now server already know about the PC that I am going to receive some message of HTTP from this PC from 10.1. 1 minute. The most interesting thing over here is what? The most interesting thing is while three-way handshake, both the devices are going to exchange so many information with each other. Like what will be the size of data that PC is going to send to server? What is the minimum MTU between source and destination? Right? Also, when I will send you acknowledgement, because after each and every packet, if server is going to send one acknowledgement, then communication is going to be very slow. So they are going to decide the window size. What will be the size of window? Right? So many things is going to be negotiated over here while three-way handshake. And now after TCP connection, my PC is going to send actual HTTP GET message. Get message. And server will send which message in the response, guys? Server will send which message in the response?
Post.
HTTP response. By the way, here we can add one more layer. Right? After TCP connection also, PC is not going to send HTTP GET message. There will be some more packet exchanged. That is for TLS connection. Right? For the encryption, it is going to exchange some more messages over here between after the TCP connection. If you will capture your WAN link and if you are going to check the data, right, there will be some more types of data like client hello. For the here we have a step of TLS connection. Nowadays we are not using SSL, TLS connect. So we will have some messages in of TLS over here like client hello, server hello, certificate, freeze here key. If you don't know what the TLS, you can leave it. Later we will discuss about TLS also when we'll see the security fundamental. For now, this is sufficient. Guys, if I am going to open the Wireshark in my laptop, which is the capturing tool, where dark. And if I will capture my WAN link, where is the traffic on the Wi-Fi link? So let me capture my Wi-Fi link. Here is the traffic on my Wi-Fi link. You can see so many traffics are there because I am connected through Google Meet. Now in the browser, I am going to type any domain name. Let's say with what, face dot www.facebook.com, right? Here. Right, I got the login page from the server. Now if I am going to search, somewhere you will find DNS request message should be there, or you can open any message. You can see in the maximum message destination port number is 443 only, right? So this is what HTTP message, right? This is transport layer information, this is network layer information, this is layer 2 information, right? And guys, source port number is random port number. You can say destination port number is 443, and many more informations are there. What I told you, one field is flag field. Here you can see, and in the flag we have so many flags. Syn flag, by default syn flag is off, not set. The set flag is there, push flag. We will talk about these all flags. This is acknowledgement message, right? So that's why acknowledgement bit is on. Here is the application layer data. Here is the transport layer security. What I told you, TLS message, TLS 1.2. So see, some messages will be there. TLS client hello message. Then transport layer. For now, you can focus over here. What are the information in transport layer header? What are the information in network layer header? What are the information in Ethernet header? The main packet flow for you. Clear, guys? Somewhere we will have DNS query message also. TCP header, or you can check it in GNS3 also. You can create same lab, this lab. You can have two daughter. You can use one daughter as a PC, one daughter as a server. Right? In the similar way, for other application layer protocols also, packet flow is going to be exactly same for all TCP messages. HTTP, HTTPS, FTP. Again, FTP is, guys, TCP based protocol or UDP based protocol? If it is TCP based protocol, then what will happen at transport layer? Telnet. Telnet is TCP based protocol. DNS is UDP based protocol. So in case of DNS, what I told you here, that this PC is going to send DNS query message, and DNS is UDP based protocol. So before sending DNS message, there will be no any control connection. For DNS, there will be no any control connection. TCP header. Here is the TCP header. You can see what are the information. Source port number of sender machine, random port number, destination port number, it can be 53, any well-known port number, HTTP port number, HTTPS port number, FTP port number, sequence number, acknowledgement number. Now, what is sequence number and what is acknowledgement number? Soon I am going to tell you that also, right? And some extra fields are there like windowing, flag, reserve, checksum, urgent, option. Let's talk about these all fields. In case of UDP, there is the UDP header. In the UDP header, you can see we have very less information. Is it visible? Source port, destination port, length and checksum. Are you able to read it, guys? Source port, destination port, length and checksum. Then I can show you the IP header, IPv4 header. We'll not talk about IPv6 header now. Version, header length, type of service, total length, identification field is there, a flag field is there, offset, time to live TTL value, protocol, header checksum, source IP, destination IP, option, and then actual data. These are the fields in IP header. And then Ethernet header. See, Preamble field is there. Start frame delimiter is there. Destination address is there. Source address is there, means destination MAC, source MAC. Length is there. Data and FCS. These are the fields. So in Ethernet header, you know about source MAC, you know about destination MAC, you know about data. In the IP header, you know about source IP, you know about the destination IP, and you know about the data. In the TCP header, you know about source port, you know about destination port. And in the UDP header also, you know about the source port and destination port. Yes or no, guys? Anyone have issue to
Yes, sir.
understand this point? No, na? क्लियर है ना ये?
Yes, sir. Clear.
Yes, what about others? Divesh. Divesh brother, what about you? Clear?
सर आपने ये जो अभी टीसीपी पैकेट फ्लो बताया ओएसआई मॉडल का टीसीपी तक टीसीपी के इधर तक उतना ही बोलना है।
नहीं, अभी हम पूरा पैकेट फ्लो देखेंगे। अभी तो मैं आपको एक पार्ट ही बताया हूँ बस, इतना ही नहीं बोलना है। In the
ओके सर।
interview, you need to mention many more things. We will discuss the overall packet flow as well. This is not overall packet flow. Okay.
ओके सर। ओके
Now you know the basic packet flow. What will be the information at transport layer, network layer, and data link layer, extra information with actual data. Now,
Yes, we understand that.
okay, okay, great. Now see the next thing. Are the port number will connection oriented handshake sequencing. Why I have sequence number in the TCP header? Just because of sequencing. For the sequencing, sequence number is used to perform sequencing. Now question is, what is sequencing? Guys, in TCP sequencing is done with the help of sequence number, you can see, which is one field of TCP header, correct? So that receiver device can arrange the segment in original order. What do you mean by this? For an example, this is PC, this is server, right? And between PC and server, guys, some networking devices are there, and this PC have sent three packet or three segment. Let's say segment 1, segment 2, and segment 3. In the segment 1, actual information is, for an example, hello. Actual information is hello. In second segment, information is I, and in third segment, information is Praful. Hello. In second, hello, let's say how are, and there is one more segment, segment number 4, where is, so my actual data is what? Hello, how are you? Why we have divided it into segment? Why we need to divide a large data into a smaller part? Because of MTU. Now understand MTU. What is MTU? Guys, MTU stands for maximum transfer unit. Let's say this is my PC. So from where PC is going to forward the traffic? From their port, from their interface only, right? And this port will have one certain amount of bandwidth, yes or no? Bandwidth. So can this PC send the data whose length is more than their bandwidth? Can we send? Bandwidth is what? What is bandwidth? Bandwidth is maximum width of band. For an example, there is one road. At this road, at a time, only one car can travel. Only one car can travel. So is it possible to travel two cars at a time on this road? Not possible, because that is not the bandwidth of this road. Bandwidth of this road can only pass one vehicle at a time, one car at a time. So a device can never send the size of data whose length is larger than their bandwidth. Similar, like here we have MTU. MTU means the maximum amount of unit, maximum transfer unit that a device can transfer. Maximum unit that a device can transfer. So for an example, MTU of this port is 1500 byte. which is the default value for Cisco router. MTU over here is 1500 bytes. Byte means 1 byte equals 8 bits. Okay, 1 byte means 8 bits. So if I am saying 1500 bytes, you can calculate the length in bits, right? And this PC have one HTTP message whose length is, let's say, 3000 bytes. So now there is issue. My device port don't have capability to transfer this data because the data length is more than their MTU size. Even guys, on the PC for an example, MTU is sufficient. On the PC, MTU is sufficient. It can send 3000 size of data, but between source and destination there is one router, and the MTU of their interfaces are 1500 byte. So even PC can send 3000 bytes of data, can transfer from this port, but router can also receive it, maybe, because I am talking about the MTU, means I am talking about the transfer unit that router can transfer, right? So when router need to transfer it on this interface, there will be issue because MTU of this interface is only 1500 byte, length of data is 3000 byte. Router have to divide it into two parts. So if router is going to perform division so many times, then CPU utilization can be increased. So better to divide large size of data into a smaller part on this PC only. So that's why PC have divided into 4 segments. But because of congestion on the link, my server is going to receive first 4 segment. Segment number 4 is received by server first. Then it have received segment number 3. Then segment number 2. Then segment number 1. Now this server have to arrange it in actual order. Otherwise, the actual data is going to be what? R, how, sorry, you are, how, and high. This is going to be actual data then. So that's why we have sequencing concept. Whenever PC is going to divide large size of data into a smaller part, it will perform sequencing. Sequencing means process of adding sequence number with segment, right? So here my PC is going to write sequence number 1, sequence number 2, sequence number 3, sequence number 4. And when the server is going to collect these all data, first it will store in their buffer memory, and from the buffer memory it will arrange it in the sequence. Sequence number 1, 2, 3, 4. So arranging data in actual order is only possible with the help of sequencing. That's why we have one field called sequence number in the TCP header. Okay. Sequencing is clear, MTU is clear. Before sending data, sender will negotiate MTU. Now question is, how my sender machine can divide largest of size of data into a smaller part? Bro, how my machine know the minimum MTU between source and destination? What I told you guys, while three-way handshake, it will negotiate minimum MTU between source and destination. Sequencing is not possible in case of UDP, because in UDP we don't have three-way handshake. The machine cannot negotiate the minimum MTU. Sequencing can be done only and only in TCP, because while three-way handshake it will negotiate the MTU, right? For an example, this is my PC. Here is one router R1. Here is one router R2. Here is one router R3. Here MTU is, let's say, 1500 byte. Here MTU is 100 bytes, let's say. Here is the server, and here MTU is 500 bytes. So when this PC is going to generate a data segment, the length of that data should be lesser than or equal to 100 bytes. Then only router will not perform division. Otherwise, router have to divide the data, and that particular thing is called, by the way, fragmentation. When your PC is dividing data, that is called segmentation, because your PC is actually not dividing the data. Who is dividing? TCP protocol at transport layer. Application layer don't have any foundation. Application layer can generate any size of data, right? They don't know about MTU. HTTP protocol don't know about MTU. They don't know what is TCP, UDP, three-way handshake. They don't know, right? This is the responsibility of TCP, transport layer, TCP protocol. So TCP protocol will check what is the minimum MTU between source and destination, 100. Then I will only send the size of data whose length is equal to 100 or lesser than 100 bytes. And sender machine already know it. Right? So here is the example, also same example. And after that, retransmission. If there is sequencing, then we can perform retransmission also. Right? For an example, sender have sent this data. Hello, how are you? Sequence number 1, sequence number 2, 3, 4. And here is the receiver machine. Because of congestion on the link, one segment got dropped, one packet got dropped. So receiver machine all have only received 1, 2, and 3. So in this case, if we have sequencing, then we can perform retransmission. We can retransmit the missing data. But in case of UDP, if you are going to miss any segment, you have to retransmit again all the data. Right? If you are thinking, Praful, why we will use UDP? So guys, if there is no connection, then this protocol is going to be faster than TCP. In the video conference, we need what? Fast communication. That is UDP based. If you are going to miss something, some of my voice because of bad internet connectivity, you will not get it again because device will not perform retransmission, because this is UDP based communication, and in UDP we don't have sequencing. If there is no sequencing, then retransmission cannot be possible. Getting my point, guys? Okay, TCP is reliable protocol, flow control, fine. Then windowing. What is windowing? So for an example, again I have same scenario. One PC is there, one server is there. Between PC and server we can have lots of devices. Later we will see. Right? For now you can assume that both are directly connected with each other. What I am saying here, if this PC is going to send, guys, 1000 HTTP data, 1000 HTTP packet. There is one movie. The length of that movie is 2 GB. 2 GB. And to download all 2 GB file, this PC need to send 1000 number of request messages. Server will send 1000 number of reply. But before reply, there is one more message, that is acknowledgement, right? After each and every segment, server have to give acknowledgement because guys, it is UDP based communication, right? So see the packet exchange, PC, server. First my PC is going to send first HTTP message, HTTP get message, let's say. Server will send acknowledgement, then server will send HTTP response message. Again PC is going to give acknowledgement of this response message, and then it will send again another HTTP get message. Like this, communication is going to be, guys, very slow. Maybe it will take 1 hour to download 2 GB of file. Right? If let's say one packet is taking 2 seconds to process, right? And if there is 1000 packets, that means 4000 packets are going to be exchanged. That means total duration can be 8000 seconds to download entire file. Yes or no? And if there are so many devices, so many routers, let's say server is in US and you are sitting in India and you are downloading the movie, then delay is going to be 30 millisecond, 40 millisecond. For the internet, you will have, let's say for an example, the connection between PC and server is poor, and it is taking 10 seconds to process one packet, then you can assume how much time it will take to download full movie. So here we cannot reduce get message and acknowledgement message, that is mandatory, but we can reduce this acknowledgement at least. So we come up with windowing technology to reduce the acknowledgement. Windowing is used to reduce the number of acknowledgement. While three-way handshake, sender machine and receiver machine is going to decide, right? Sender machine is going to ask to receiver machine, server, hey server, what is the size of your buffer memory? How much data you can store in your buffer memory? So, for an example, server can store 10 MB of data in their memory. 10 MB of data in the memory, or let's say 5000 bytes of data in the memory. Bytes of data. So PC is going to say, do one thing. Just don't send acknowledgement after each and every HTTP packet. First store 5000 bytes of data in your buffer memory and then give me one acknowledgement. Again I will send you 5000 bytes of data, then again give me one acknowledgement. Again I will send 5000 bytes of data, then give me one acknowledgement, like that. Right? So let's say first packet is now, length of first HTTP packet is 1500 bytes. Again it will send 1500 bytes. Again it will send 1500 bytes without acknowledgement. After sending 5000 bytes of data, PC will stop. Now PC will expect first acknowledgement, and after that it will start sending rest data. So this way we can reduce the number of acknowledgement with the help of windowing. So guys, in windowing, both the device will negotiate their buffer memory. The device will elect least buffer memory as a window size. Sender machine will send data equivalent to window size and then expect acknowledgement. Then expect acknowledgement. Right? So with the help of windowing, we also achieve flow control. Windowing is used to reduce number of acknowledgement. So here you can see buffer memory of server is 700 bytes, right? So client machine is first sending 100 bytes of data, then again 100 bytes, again 100 bytes, 1, 2, 3, 4, 5, 6, 7. After 700 bytes of data, server is giving acknowledgement. Right? How it is possible? This is possible just because of TCP connection. Because between client and server there is one guys control connection, connection. And how machine have established this TCP connection? With the help of three-way handshake. In the three-way handshake, both machines are going to exchange some messages, SYN message and SYN plus. Total 3 number of messages are there. Okay. Then there is four-way handshake also to terminate the connection. To terminate the connection, when sender PC will send their all data, then it is going to send FIN bit on TCP header. This is TCP header with FIN bit on. Instead of SYN, this time FIN bit is on, means FIN means finish. Finished. Then server is going to give acknowledgement of finish bit, and it is also going to send their FIN bit. Again sender will send acknowledgement. After that, my server is going to terminate the connection. Right? Now buffer memory is free. The port number is free. It can now establish connection with any other device. Right? So if the client and server have established a connection, they have to terminate it as well, because guys, a server can maintain limited number of connection at a time. Let's suppose this is Google server and lakhs of people from the globes are accessing Google website at a time. But for an example, these devices have capability to handle 1000 number of connection at a time only, or 100 number of connection at a time only. Right? That means only 100 machine can access the web page of Google at a time, right? So if you are accessing, still if you are using on the Google web page, then fine, otherwise it is going to terminate the connection. When you will close the tab, it is going to send fin message and it will terminate the connection. After that, network layer, you know about network layer, data link layer, physical layer, PP, PDU. PDU means protocol data unit. This is nothing but the payload, right? The actual form of data at particular layer. So what I told you, at application layer, we are going to call data to data only, but at transport layer, we are going to call data to segment, at network layer packet, at data link layer frame, and at physical layer bits, right? Then encapsulation, decapsulation, you already know this. TCP, UDP header, and here is your TCP header. Right, again you can see we have same information. Source port, you already know. Port number of sender device, destination port, you already know. Sequence number, you already know. Acknowledgement number, you already know. Window size, you already know. Correct, guys? Am I right? Is these points clear to everyone?
Yes, it's clear.
You know something about flags also.
So one question, sir, Miss, as you said from the segmentation, Miss PC is generating the Miss TCP is checking about the your window size, Miss, your this Miss segment size. Sorry, Miss how much it has to be sent MTU size. Sorry. So in the fragmentation, how router also will perform it, or it is going to be from the PC end only?
A router can also perform. The router can also divide the data into a smaller part, and that particular thing is called fragmentation. When router will divide the large size of data into a smaller part, in case of UDP. In case
Okay,
of
it is
TCP, router don't need to divide, na, because my machine already know about the MTU. But what about
okay.
UDP message or the data which is generated at layer 3?
Mhm,
Router
mhm.
have to divide those data which are not
Okay.
TCP based.
Okay,
So
so it is going to, because 1500 is our default size, so it is going to be to limit that that rate only,
yes,
1500.
yes. So if router have received one UDP message, let's say whose length is 300 bytes, 3000
Mhm.
bytes. So router will divide it into two part, three part like that.
Okay, so this time UDP will be performing this operation, right?
No, no, router, your
Mm.
router will be performing this operation. Means
No, with the
network
help
layer
of,
protocol, IP protocol.
okay, IP. Okay, this time IP will helping. Means
Yes,
as you said, means segmentation, TCP will be helping them
correct,
to identify, right?
correct, correct.
Okay, okay, sir. Thank you.
Router works at layer 3 only, right? So most of the task of router will be performed by IPv4 protocol.
Okay, sir. Okay, got it. Thank you.
Now let's understand about rest field. This one is, guys, header length. Means what is the length of this header? Why it is important? So that receiver machine can understand the length of actual data. If transport layer at receiver device, this TCP protocol have received this message, right? And this is TCP header, this is actual data, right? So let's say total length of this data is 100 bytes and header length over here is 50 bytes or 20 bytes. That means the length of data is 80 bytes. It can find the length of data. That's why we have header length here. Reserve field is here and flag field is here. Some more fields are there like urgent field. Urgent field is used for QS, quality of service, to send the data urgently. Why we have urgent field? To send the data urgently. If you are going to on this bit, then routers or whatever devices are there between source and destination, those devices are going to process this data first, this segment first. And then we have one checksum field, one reserve field. checksum, what is checksum, guys? Checksum is used for error detection. Error detection. Checksum is similar like juicer. You all know about juicer? If I am going to put oranges here, then I will get orange juice. Yes or no? If I am going to put apple, I will get apple juice. In the same way, what will happen when transport layer is going to receive the data? It will add the header. Before adding the header, it is going to put all the data in one algorithm. Like this juicer, I have one algorithm here. I'm going to put all the data in the algorithm, and this algorithm will find one hash value for me. Right? Let's say hash value is A12B. This is the hash value. And sender machine is going to add this hash value in the TCP header. A12B hash value, and then it will send to receiver machine. When receiver machine will receive the data, receiver machine is going to check, hey, let me check, this data is not modified over network, because between source and destination, let's say internet is there. On the internet, guys, bad people and good people, both types of people are there, right? So someone can modify my data as well. They can change the destination port number, destination IP address. Then, so what receiver machine will do? Receiver machine will also remove the header, and it will also put same data in the same algorithm. And it will check, am I also getting same value, same hash value, A, 1, 2 or B or not? If the hash value will match, that means data is not modified. If hash value will not match, that means data is modified. Right? For an example, if I will give you one example, let's say MD5. You might have heard about MD5. MD5 is one algorithm. Right? So here in the browser, if I will say MD5 calculator, and here I am going to give one data, let's say hello. Is it visible, guys? I'm saying hello, how are you? This is my data. So I have put the data in the algorithm. I am going to say calculate one hash value for me, and it have calculated two hash value for me. One is this one and one is this one. Now if I am going to modify anything in the data, right, even if I will add one dot, right, my hash value is going to be different. You can see the hash value is now different. So these are the algorithm for calculating hash value, and with the help of checksum field is going to carry the hash value, right? Why we are using it? For error detection, to identify is there any modification like that. Is there any error? And here is the deep brief of all the section: source port, destination port, sequence number, acknowledgement number, header length, reserve field, which will be always set to 0, right? We will use it in future. Now we are not using it. Flag field. Flags. Flag is used to perform flow control. Control function which is used to set up and terminate session. Through flag, we can establish the session, we can terminate the session, right? And how many flags are there? Total 8 flags are there in the TCP header. Out of 8 flag, one is SYN plus ACK, one is FIN. You know about this flag. And some more flags are also there. We'll see that later. Then window size is there. Checksum field is there. Urgent point and option. Now I am expecting you know all the fields about TCP header. Yes, guys?
Yes.
Sir, this RSV reserve. This RSV is reserved.
Reserved.
Okay. Mhm. And this high L HL, sorry.
Header length.
Okay, HL. Okay. What does it do, sir? Can you
It is
repeat
going to
this?
carry the length of header. What is the length of these extra information?
Okay. So have any prerequisites for it? Some defined size, or it is
Prerequisite
means
means,
flexible? Means it has a fixed length, or it is means varying according to the
yeah, it
applications.
can vary, right? In most of the cases, it is going to be 20 bytes.
Okay.
Header length of TCP is going to be 20 bytes. Header length of IP header, IPv4 header is also 20 bytes. 20 bytes, 20 bytes. So guys, tell me, if the minimum MTU is 15,000 bytes, then what should be the length of my segment? Or should length of my data? What should be the length of my data?
1480.
1460. 1460 plus 20 bytes TCP header plus 20 bytes IP header, total 1500 bytes. Now in the UDP header, we have a few information you already know about these all. Then IP header. In the IP header, some fields are so important, like TTL, like protocol, source IP, destination IP. Identification will be used in case of fragmentation, fragment offset also. Flag is there. Priority, this field is again for quality of service. Header length is going to carry the length of header information. Total length is going to carry the length of data plus payload plus IP header. Version is going to carry IPv4 or IPv6. Right. So see about each fields, brief about each fields. Type of, don't worry about the type of service, because we will have a separate class for QS later where we will discuss this field in detail. Identification field. As if the IP packet is fragmented, it means if router is going to divide IP packet, then each fragmented packet will use same 16 bits identification number to identify to which IP packet they belongs to. Right? For an example, router 1 have received one MTU is 1500 bytes, and it have received one packet whose length is 1000 bytes. So now router is going to divide it into two parts. How R2 will get to know about it, that these two IP packet belongs to same packet. Let's say router 2 MTU is 2000 bytes. So router 2 can combine it if it is fragment packet. Right? So here router 1 is going to use identification number. Right? Same identification number will be there on both the packet. Let's say 1 or 10, 10. So when router 2 will see, okay, identification number is same on both the IP packet, on both the fragment packet, that means I need to combine it into the single IP packet. This is the use of identification field in IP header. Whenever router will perform fragmentation, it is going to use identification field to identify which packet belongs to, or which fragmented packet belongs to which IP packet. Okay. And here if I will talk about the IP flag, so there are 3 bits, 3 flags are there. First bit will be always 0, that is not in use. Second bit is called DF bit, means don't fragment bits. If I am going to on this bit, then router will never perform fragmentation. If I will off this bit, then router will never perform fragmentation. If router is going to receive the data whose length is more than their MTU, then simply router will drop it, discard it. It cannot perform fragmentation. The last bit is called more fragment bit. More fragment bit means the more fragmented packet is coming. The more fragmented packet is coming means this is not the last fragment packet, right? The last bit is called MF, more fragment bit, set on all fragment packet except the last one. In the last fragment packet, this bit is going to be off. That means it is the last packet of last fragment packet. Okay. Then fragment offset is there. It is 13 bits specific position of original fragment IP packet. See, I am going to show you the fragment packet in the GNS3 while practical. It will be better for you to understand, right? What is the meaning of fragment offset? It is going to, by the way, identify the position of original fragmented IP packet position and time to live. What is time to live, guys? Time to live is used to avoid the loop. Later you will learn how loop can form in the network. R1, R2. Guys, here also we have chance of loop. Let's say here I have one PC. Here also I have one PC. This PC is using IP address 10.1.1.1. This PC is using IP address 20.1.1.1. So router 1 know the IP address of PC where PC is connected. Router 2 know about PC 2. Right? So to make communication, guys, I am getting noise. Please put yourself on mute. So here router 1, PC1 and PC2 cannot communicate with each other because router 1 don't have route for 20.1. So here if I am going to say, bro, whenever you need to forward traffic to 20.1.1.1 or like 20.1.1.1, if I am saying let's say 30.1.1.1, whenever you need to forward traffic to 30.1, just forward it to R2. And by mistake on router number 2 also have configured same thing. For 30.1.1.1 forward traffic to R1. So in this case, if this machine is going to send traffic to 30.1.1.1, what will happen? It will forward traffic to R1. R1 will forward to R2. R1 will forward to R1, right? And packet will be moving between R1 and R2. And this loop is for lifetime. For lifetime, this packet will be moving. Unnecessary, there will be congestion, chip utilization, right? Low performance. All the issues will start. Will start facing these. So that's why here what TTL. All the operating systems have their own TTL value. For Cisco IS, I have what TTL 255. 255. And guys, whenever a packet is going to cross the router, right? Whenever router is going to process the traffic, forward the traffic, it will reduce TTL by 1. Right? So here is the PC, here is the another PC. If this PC will generate traffic, TTL value is going to be 255. It will add TTL 255. It will forward to router. Router will reduce it by 1. It will become 254 over here and then it will forward to this PC. Right? Now between router 1 and router 2, R1, R2. If I have loop, right, in the first packet TTL value is 255. In the second packet, when router 2 will forward it to router 1, TTL will become 254. When router 1 will forward to router 2 again, TTL will become 253. And after some time, after 255 packet, TTL value is going to become 0 on maybe on router 1 and router 2. On TTL will become 0, router will discard the traffic. This way we can avoid the layer 3 loop. So that's why here we have TTL field. If you are going to generate message from the Windows operating system, TTL value is going to be 255. After that, protocol field is there. This is the so important field of IPv4 header. Protocol field, guys. So this protocol field is going to tell tells us which protocol is encapsulated in IP packet. You know, network layer or internet layer is going to add IP header with the payload. So who have handover payload to IPv4 protocol? That will be the information inside protocol field. So here is my network layer. At network layer we have some protocol like IPv4, IPv6, OSPF, IGRP is there, ICMP protocol is there, right? Then transport layer protocol is here. Transport layer can also hand over data to network layer, right? So if IP protocol is going to hand over data, right, then there will be protocol number of. If OSPF is going to hand over, the payload belongs to OSPF, then protocol number will be the protocol number of OSPF. If TCP protocol is going to send payload to network layer, then protocol value will be protocol number. Each and every protocol, whether it is transport layer protocol or network layer protocol, both layer protocol, transport layer and network layer protocols have a unique number to identify their identity, and that number is called protocol number. For an example, OSPF have unique protocol number, TCP protocol number is, UDP protocol number is 17, like that. So through protocol number only we can identify the payload. Payload belongs to which protocol at network layer. Like guys, in the TCP or UDP header, how we can identify the service? Application layer protocol. In the TCP, how we can identify application layer protocol? By checking destination port number. If destination port number is 443, that means application layer protocol is HTTPS. If destination port number is 53, that means application layer protocol is DNS. In the same way at network layer, if protocol value is 1, that means it is ICMP packet. If protocol number is 6, that means it is TCP message. If protocol number is 17, that means it is message, like that. At each layer, you have to identify the upper layer information also. Then only you can hand over to the correct protocol at receiver machine. At receiver machine, how IP protocol will get to know that this message, the payload belongs to UDP, belongs to OSPF, ICMP, EIGRP. भाई किस प्रोटोकॉल को देना है आखिर? Take the protocol field, right? So these are the fields of IP header. Hope it is clear. And guys, then there is difference between segmentation and fragmentation. So what I told you, segmentation means dividing large size of data into smaller part at transport layer. The meaning of both segmentation and fragmentation is same, dividing big data into a smaller part. Segmentation also, fragmentation is same. First difference, it will perform at transport layer by TCP protocol, and fragmentation will be performed by network layer by IPv protocol. Segmentation will done on the basis of maximum segment size, and fragmentation is going to done on the basis of MTU. What is MSS, guys? Maximum segment of size, right? MSS is nothing but MTU minus header length. Right? If minimum MTU is 1500 bytes, then segment size should be, data size should be 1460 bytes, because we are going to add 20 byte TCP header, 20 bytes UDP header, so total length will be bytes. So this 1460 is nothing but maximum segment. So here are the differences you can see. And guys, segmentation will be performed for all application layer protocol which uses TCP at transport only. At layer 4. Fragmentation for all UDP based traffic and network layer traffic, where we are not going to use. And then we have some application here. Now about application layer protocol, what you need to learn, guys, about most of the protocol you need to learn these things: what port number they are using, what services they are using at transport layer, TCP or UDP, and then what is the function of that protocol. Like HTTP uses port number 80 at transport layer, and it is used to access web page from the web server, and this protocol is not secure. HTTPS uses port number 443, uses TCP protocol at transport layer, and it is again used to access web page, but this is secure protocol. Telnet. Telnet is the application layer protocol, uses port number 23, TCP service at transport layer, and it is used to take remote access of network. Again, it is not secure. SSH uses port number 22, TCP, and to access networking devices remotely, and this is FTP, port number 20 and 21, TCP service, and used to access files. Right? So you can see about all application layer protocol like NTP, network time protocol. What is the use of this protocol? Why we are using it? What port number and what service? These are so important for you to troubleshoot the. Apart from it, you don't need to learn how developer have developed the NTP protocol. What is the coding behind it? How protocol look like? Doesn't matter for you. This is application layer service. This is already enabled somewhere. If devices are not able to synchronize the time, you need to troubleshoot. That's it. And to troubleshoot, you need this information. Then DSCP, by the way, DSCP is so important for you. You have to learn it in detail, like DNS and DSCP. These are the important protocol only. Any question, guys, still here? Now you can understand the packet flow. Yes.
Hi, please, I want to ask with some protocols that has TCP, why are they not still secured?
It is not secure. What is the meaning of secure?
Like you put it in the notes that they are TCP, but they are like HTTP, and
HTTP is not secure. In HTTP, your data is going to travel in plain text. Right? Your actual data is, let's say, hi, how are you? Hi, how are you? So anyone on the network can capture it and they can read the data. But in case of HTTPS, data is going to be travel in form of encryption in different format. Device is going to perform encryption for HTTPS traffic. That's why we are saying that is secure protocol.
okay, thank you.
For an example, this is my host. See, and here I have one server also. Secure means the both types of data, your data and data and plain. Okay, let's say this is my scenario. Here we can test something, right? Whatever things we have in the header, we can test over here. For an example, CIP address is 10.1.1.1. Router interface IP address is 10.1.1.10. Server IP address is 20.1.1.1. And interface of router is using 20. My topology. Let me try to use some flag bits of TCP header, right? Uh, Let me show you the protocol fields in IP header. To see the messages, you can capture the link. I can capture any link. Let's say this link. I'm going to capture it. And let's start the configuration. Guys, again, if anyone is not familiar with the configuration, don't worry. Anyone is not familiar with configuration, don't worry, we'll see the configuration also later from the configure, config t, routing. Well, I am going to tell the route. So but dash dot 1.1.255 dot 255 dot so called 10 router 1 dash dot 1.0 also API dot 1. Here if I will show you the MTU, so IP interface F space F0/0 root. So what is MTU, guys? Here what is the MTU? 1500 bytes, right? By default MTU of all the interfaces is 8 byte. Now let me configure the server interface F0/0 no such and IP address 20.1.1.2.0 exit IP routing IP default gateway .1.1.10. Done. Now if I will ping from PC1 to server, ping will work. Ping 20.1.1.1 and you can see ping is working, right? And here in the capturing you can see the message. So guys, for the ping you can understand the packet flow, because in the ping is a utility which is used to check connectivity between devices, right? But definitely ping is using one protocol behind the scene. That protocol is called ICMP protocol. Ping uses ICMP protocol, Internet Control Messaging Protocol, and this is layer 3 protocol, layer 3 protocol, L3 protocol. So that's why you can see in the ICMP message we will not have TCP header. Are you able to see TCP header here? No. This is ICMP actual message. Then internet header, like network layer header is there, the layer 2 header is there, and layer 1 information. That's it. We don't have here transport layer information. Source IP, destination IP, source MAC, destination MAC, those are the information here. Tomorrow we'll see. Ping is working, guys. If I am going to define here size of ping is, let's say 2000 byte. Now tell me, will ping work? Will ping work?
No.
When I can start capturing over here also. Let me do one thing. Let me stop the capturing.
Yes.
Yes, tell me, will ping work?
No.
Definitely my PC is not going to divide the large size of data into a smaller part, right? My PC will generate 2000 bytes of data. and it will forward to router 1. Now router 1 MTU is 1500 bytes only. Router 1 is going to forward it from F0/1 and MTU of their interface is only 1500, so it cannot send this amount of data. Router have to perform what then? Segmentation. Guys, if I am not going to define the size here, you can see very simply ping is working and there is no segmentation. Router is not dividing data because you can check the length. Total length of data is what? 100 bytes only. Total length of data is 100 bytes, so you don't need to divide it. But if I am going to define the size over here, size 2000 bytes. So in this case, what will happen? You can see fragmented packet now, fragmented IP protocol, correct? So now router is performing what? Fragmentation, and that's why you can see ping is working. This is able to communicate. Delay is 92 millisecond. In 92 millisecond, it is getting the reply message. But if I am going to set don't fragment bit over here, DF bit, then will ping work? Then ping will definitely work, because now we are telling to all the devices between source and destination that you are not allowed to divide this. Yeah, ping is not working, you can see, right? Again, if I will remove the don't fragment bit, again ping will start working. So what it told you about the fragment field, more fragment will field and do not fragment field. If the do not fragment bit is on, then your router is never going to divide the data. If by default all the bits are off only. Now you know about the header, you know about the application layer protocols. Now tomorrow first we will see the packet flow in case of ping. So when layer 3 protocol will generate message, and after that we'll see packet flow for application layer protocol. For here, if I am going to use any HTTP protocol, sorry, any TCP based protocol, guys, any TCP based protocol can be my telnet, and if you want to check the which port number is by default enabled, let's say on the server I want to check which port number is enabled, so there is one command to check that by default. So control plain host open port. So which port number is enabled by default? Only one TCP port number, that is 20, is reserved for. This server is listening for this port number only by default, right? If I am going to enable HTTP service over here, IP HTTP server, and then this command. Now you can see how many ports are on. How many ports are on, guys? Ports are on now. HTTP and telnet. If I am going to enable HTTPS protocol, IP HTTP secure server. So this is secure server, that's why it is creating crypto key, it is getting RSA key, right? We will learn about this, don't worry. Now 3 port numbers are on: 443, 80, 23, and automatically SSH is also enabled. Whenever you will enable HTTPS protocol, automatically SSH protocol will. So these are the by default open port on my, not by default, we have enabled these all ports on my, right? If I want to configure this server as DNS server, right? So I can say IP DNS server, then you can see port number 53 is also enabled now. port number 53 is also enabled. Now in the DNS I can create database IP DNS, and then we can say what? IP DNS. Here we can server www.cmnet.com, and after that the IP address of cmnet.com. There is one command to write create database as well over here. Getting that command IP DNS, maybe the command is not available on this particular server, but like this we can enable the service, right? And now from the PC guys, if I am going to send, let's say, any telnet data, telnet and 20.1.1.1, so password is not set, that's why connection is refused. Let me set one password over here. Enable password go 123 and line by 024. Here password I am going to configure again Cisco 123. And now from the PC, if I will access the server, it will ask me for password. Password is Cisco 123. Now you can see I got the access of my server, and here I can run enable command. Again it will ask for enable password Cisco 123, and I can check the TCP brief. Now telnet connection is there between PC and server, and telnet is TCP based protocol, so you can verify the TCP connection. So TCP brief, here is the TCP connection. You can see between 20.1.1.1 and 10.1.1.1. 20.1 is the telnet server who is using port number 23, well known port number of telnet, and 10.1, which is the client, is using any random port number, and the status is established, right? So until and unless I will have this telnet connection, I will be using this session, we will have this TCP connection. Okay guys, right? If I am going to say here what telnet 10.1.1.1, and then if I will define the port number here, telnet and 10.1.1.1. Here I can call port number 443. Connection used, and so notable for 443 port number. But in the capturing, where is the capturing? In the capturing, you can verify that there will be TCP message. Server is sending TCP message. So for all TCP based protocol, first it will establish this TCP connection and then communication. Over that connection only it is going to send actual data. And once I will terminate the telnet session, the connection is also going to be on the PC. Also you can see I have same console. Server, on server also I have same console. So yes, here you can see online VTY interface. One user is sitting whose IP address is 10.1.1. So we'll see the packet flow in next class in more detail, but whatever topics today we have covered, those are as essential part of the packet flow. If you know the headers and protocols at each layer, then only you can understand the packet. If anyone have any question from the today class, please ask.